Welcome back to the Molpigs podcast. Today, our guest is Kent Kemmish. Also with me today are Anastasia.
Hello.
Boya.
Hello.
Georgios.
Hello.
And I'm Will. Kent Kemmish is the CEO and founder of demonpore Incorporated, a biotech startup building a nanopore-based molecular sensor, the demonpore 64, marketed and designed as a gaming console. His background includes drosophila research, age-related aggregates, a number of previous startups, as well as live theatre production. Kent, hi.
Hi, Will. Oh, thanks for that introduction. I didn't expect the live theater production to come up, but okay.
Well, I saw in your bio,
Yeah.
So I thought I couldn't not bring it up. So I'm sure we'll talk about that in a bit, but for now, I think the question on everyone's mind is, what is the demonpore 64?
The demonpore 64 is an advanced scientific instrument disguised as a toy. So it's a molecular sensing, a single molecule and single cell sensing instrument based on nanopore technology that you can use you can play games with friends from around the world while solving important biomedical and synthetic biological problems. It's basically a box with some electronics and easy to switch out nanopore cartridges so that you can test a bunch of different nanopores, use a bunch of different nanopores to play different games that the different nanopores go with.
Just to jump in, for those who don't know, what is a nanopore?
So a nanopore is a tiny hole, and it's a tiny hole in a barrier between two reservoirs of salt solution. And you set up an electrically induced flow of salt ions that have to traverse this tiny little restriction point. And that's like an electrical circuit where the nanopore itself is a resistor. And the sensing is based on how different molecules or cells block that flow of ions. That gives you a sort of fingerprint of the individual things that you're looking at. And nanopores go back, that basic idea goes back to the 1940s. The first one ever made was just poked in the cellophane wrapper from a pack of cigarettes because Wallace Coulter didn't have any money to do anything fancier, but he managed to make like a 70 micron hole in a cellophane wrapper by hand, and he saw the first electrical signals from single cells passing through that little hole that he had poked by hand. And when you get a complete blood count, when you go to hospital, get a lab diagnostic drawn, one of the most common ones you get is a complete blood count, and that is those are still done based on the same idea of passing things through a tiny hole. 98% of them or so.
And how does that lead into gaming consoles?
So how did we come to gaming consoles? So for years I was focused on a sort of business model with advanced genomic technologies that basically involves getting some kind of patentable breakthrough and getting something, getting a really compelling proof of concept, raising tens or hundreds of millions of dollars, and creating a high-end turnkey instrument for the several thousand people on Earth who might immediately know what to do with it. So very capitally intensive to go from an initial breakthrough or an initial invention to something that's just ready for scientists to use. And in the case of demonpore, we developed this mechanical nanopore technology and got the really cool proofs of concept. And at around the same time, I found myself very much drawn to, well, how do we make something that a huge number of people will want? And then it went from, well, if a huge number of people want it and it's cheap enough, what would be the scientific consequences of being able to coordinate them in some fashion? And part of the important thing about what we're building is not just that it's a gaming console for individuals to buy and play with to contribute to science, but it's what happens when you have enough single cell and single molecule sensors networked in some fashion, where you start to be able to apply or think in terms of network effects with scientific instrumentation, as opposed to the classic model of siloed researchers working furiously away in the middle of the night with their own expensive fleet of instruments on their floor at whatever institute, which is great, which is something I love.
So it's a bit like a citizen science thing, right? Except that instead of the old examples that people might be familiar with, like folding at home, this is something that people can hold in their hands and actually feel like they're kind of really contributing and really doing science.
Yeah, so it extends the idea of citizen science. Instead of calling them citizen science, scientists, we call them player scientists, and it's hoping to expand the appeal of basically contributing to something bigger than what you can do by yourself. But it also brings in this other level where you're helping to hack this physical technology in a way that's very much rooted in where you are and what you are. So the fact that you're actually independently collecting data on cells and molecules from inside you and around you with this thing right in front of you that's right there. It's not in the abstract. It's not just something you're contributing CPU cycles to, but it's something you're physically doing right there to create a gaming experience. I think that's part of what's unique and compelling about a molecular gaming console. And the broader question is it's a very intuitive like rush of things into the world, like going down this path and not the conventional biotech instrumentation path. Involves a lot of calculations and vectors, etc.
Yeah, so you mentioned the mechanical nanopores. Is that something that differentiates demonpore from conventional nanopores?
Well, we have plans to use mechanical nanopores in the console itself. There will be some interesting surprises on the hardware side that'll be coming out. That'll take advantage of all the work that we've done with mechanical nanopores. But the base model, the main point of the instrument is just to make it very, very quick and easy to switch between different static nanopores. If you can quickly switch between static nanopores, that opens up so much capability for a scientific instrument. It means that not only can you use nanopores of different shapes and sizes, you can get into different materials and functionalizations. So there's a wilderness of different types of nanopores, both biological pores and solid state pores, and they're made in a ton of different ways. And they all have different ways of interacting with analytes, different ways of affecting the electrical noise in the system, etc. And we don't necessarily know yet, as a community of nanopore scientists, we can't necessarily point to a given analytical challenge and say this is the ideal nanopore for it. And everything is shifting. New nanopores are being made all the time. And even if we just talk about protein nanopores, new lumens are being designed all the time, new restriction points, and people have been doing experiments on many variants of just protein nanopores for decades now. So yeah, there's that's the mechanical nanopores. When we bring mechanical nanopores back into it, we'll start to get into fancy land very quickly, where it's not just about convenience, but on a per sensor level, it starts to become more powerful. But right now, the important things are to get toy-like ease of use and to get it into a lot of people's hands. Because even more powerful than being able to mechanically shutter a single nanopore, which is a very potent approach, is the idea of just the scale that you can get from having a bunch of people collaborating and basically pursuing the same experimental flow from a higher perspective.
So on that note, you're mentioning that you can swap out different nanopores. Presumably that would be part of the gaming interface. And I'm guessing you have lots of other games out there, and name's also demonpore 64. So are you using Nintendo 64 as inspiration for your games?
And 64 came from a lot of different places. It rhymes. It evokes my favorite computer from my childhood, the Commodore 64. Commodore 64 forever. It's hard to explain. It's if you were a geeky 11-year-old in 1986, 1985, and you had to choose between the Apple II series and the Commodore 64, I kind of wish we were in the world line where Commodore was the biggest company on Earth. Just because the whole feeling of using it was so more pure than the Apple II. I'm an Apple fan now, but
yeah, I wish that I kind of grew up in the homebrew world that era was. I mean, none of us were alive, unfortunately, in 1986, but it definitely sounds like a really exciting time.
Yeah, it was when I like, there was a time in my life from like the age of 10 to 12 where I just shut out the whole world and learned to code on the Commodore 64. It was all I cared about. It was the thing I love most about the operating system is just that you turned it on. You turned on the power switch and you were in the operating system. Like, you just command prompt. That was all. It was just you and the command prompt, and you could start programming. And there just didn't seem to be that many barriers between your creativity and the ability to build things. Whereas with the Apple II, like, I didn't like the fact that you always had to boot stuff from a disk. Like, that kind of ruined it for me. Very, very pure, very idealistic and pure-minded. Just like, let me turn the thing on and be programming. I think that was the biggest part of the appeal. So the demonpore 64, it evokes the Commodore 64, and it rhymes. And it also evokes the Nintendo 64. So it has it crosses two slightly different generations in the 80s and the 90s. And of course, 64 is an obviously very important number in biology. 64 codons. That's kind of an obvious one. But there are also many different ways in which we can think of the architecture in the final product as having 64 of various different kinds of things. There's the possibility that we may do some nifty hardware tricks to be able to get as many as 64 channels. Don't quote me on that. That's not one of the main. That's not a baseline objective of the full product launch, but there may be some nifty tricks we could do to get 64 independent channels. But there are some other ways in which the number 64 can potentially be relevant in a directly technical way.
You've told us a lot about the number 64, but I want to know why it's called the demonpore and why you're the chief exorcist officer. Do we need to sell our souls to buy one of these?
No need to sell your soul. And please don't sell your soul, even if you don't think souls are real. There's this great blog post about like why you shouldn't sell your soul, even if you don't believe a soul is a real thing. Just keep that in mind. No, so demonpore comes from. So the first time I described to someone this idea that I'd had for how to build mechanically shuttering nanopores, the very, very simple concept that I came up with independently, it turned out that I wasn't the first person in the world to think about it. Surprise, surprise. But we were the first people to actually do it, which is essentially stacking two nanopores on top of each other and moving them relative to each other to change the effective cross-sectional path for ions. And if you think about being able to do that, there are a lot of nifty things you could achieve, and a lot of things we did achieve with that basic idea. So, for instance, so let me go back to demonpore. That's what you asked about. Why it's called that, and then we can talk about the implications. So it's called demonpore because this basic idea of a gate opening and closing, of opening and closing a nanopore by basically having a shutter or something like a mechanical aperture or an iris. And we ended up doing it in a lot of different ways, but I was describing this to my friend, and he just immediately said, "Oh, you should call them demonpores," because, and it was obvious to me why when he said after Maxwell's demon. But if you're not familiar, Maxwell's demon is this classic thought experiment in thermodynamics that is based on some notes that James Clerk Maxwell scribbled down in the 19th century, where he posited the idea of this magical gatekeeper that could open and close a door between two chambers. And on one side, you would have a gas, a volume of gas molecules, some of them moving quickly, some of them moving slowly. And the demon would see the gas molecules coming, and when he would see a fast one coming, he would open the gate and let it through to the other side. And you could get free work out of this if you could just take the faster moving molecules and move them to the other side. You could get a heat engine. You could extract energy from the fact that you're making one side heat up and have more energy in it. So Maxwell didn't call this a demon. I think he used the term supernatural imp or something. And it was actually Lord Kelvin who came along, the guy that the Kelvin temperature scale is named for. He came along and called it Maxwell's demon like 40 or 50 years later. And it wasn't really ruled out as a potential violation of the second law of thermodynamics until like information theory came along like a century after Maxwell.
Yeah, Szilard and Landau, like 1920s, 1950s.
Yeah, it took a long time to actually decide, you probably, and that's because you would pay a cost energetically in information processing. And that was kind of the missing piece. But that's why we called them demonpores. And then when we started thinking in terms of the gaming console strategy, demonpore is a kind of ridiculous but memorable, fun name that gives you a chance to explain some science, and it sticks with people, and it rhymes with 64. And I didn't want to change the name of the company because I love the name. So just think of demonpore as like Commodore or Nintendo. It's like the brand name, and 64 is the name of the model of the instrument.
Yeah, and if you'd like to learn more about Maxwell's demons, you can check out our podcast with Tom Oldridge from back in January, because he talked a lot about that too. and about how we could implement that with molecules. And maybe there's a way of actually incorporating Maxwell's demon within like solid state nanopores, aside from the mechanical idea that you just described.
Oh, wow. Wait, did you guys specifically talk about Maxwell's demon in solid state nanopores with that?
Not solid state nanopores, but about non-equilibrium information in biology and strand displacement reactions as evidence for whether or not Maxwell's demon could be true.
Well, yeah, wow. I love that. I'm going to have to listen to that. So my understanding is like there is still like some kind of weird little crevice in theory where something like Maxwell's demon could be implemented. And I'm gonna Dunning-Kruger the math of it. I can't go any further than that, but that sounds really interesting. I gotta check that out.
So what are the games that we can play now on demonpore 64?
So right now you can't play any games except Spike Hunter, which is just the game that we've played in development mode with. So basically right now where we're at is we have several sets of the hardware for the instruments in different people's hands around the world, mostly in the United States, but in a few other places. And we've played this game called Spike Hunter, which is incredibly simplistic. It's a pun on Spy Hunter, and it's just a point system for observing translocation events.
So you're playing the demon in Maxwell's demon, then you're measuring the translocations.
Yeah, I guess you could think of it that way. Yeah, I mean, there's no way we would ever violate entropy that way, but we could. I mean, we have with mechanical nanopores made a gate that grabbed and released nanoparticles. That's one of the cooler things we managed to do with the mechanical nanopore thing. But I think to those boya who asked about the games, I wanted to finish that off and just mention that the first games will actually be playable by the Alpha League this summer, and that the first games we play are very much oriented around the science. And they kind of have this RPG strategy puzzle kind of flow to them, and they're longer term and they're more involving. But we're also working on something simpler and more kinetic and action oriented that someone can play without necessarily doing a deep dive on any of the science. But we're going to be announcing alpha console availability here in a couple of weeks. We think we're aiming for the first week of June to start taking applications. And basically, there's going to be we're gonna release up to a few hundred of these out into the wild and do the first collective molecular gaming. And we'll be shipping consoles later this summer.
Is there a way people can keep up to date and kind of hear the news when it's possible for them to join the Alpha League?
So yeah, right now the main platform that we'll announce those things on is the Wii Funder campaign. It's WiiFunder.com/demonpore, and everyone who invests the minimum is going to get a free console set aside for them. And that's at the full launch. That's when it's turnkey, many fewer bugs, straightforward, fun, smooth experience. The alpha launch won't be like that. The alpha launch, there will still be changes to the hardware. There's going to be a lot of bugs worked out with molecular TV. It's really for people who just have to have one. Just cannot be denied. We will and we'll be playing the first molecular games together this summer.
So for those researchers who kind of absolutely have to have one to kind of start building out a game that they might want to get people to play, what kind of experiments or research does kind of democratizing or decentralizing these like all these solid state nanopores enable? What kind of research is now would be accessible to people like just by getting so many nanopores into the hands of so many people?
Yeah, so you anything that involves getting information from individual cells and molecules, which is a huge number of possible things. If that's a point in any kind of your in your experimental workflows where you can ask, I want to be able to see cells and molecules in solution. From there, you can look at, for instance, let's just take the game Dragon Tyrant Must Die, which is going to be about rejuvenation biomedicine. The first games we're going to play with that the first sessions that we'll play with that are going to be around detecting advanced glycation in products on proteins. Basically taking mixtures of sugars and proteins and looking for the signatures of the ultimate end products of the Maillard reaction. So, quick note on aging science: we are all slowly cooking between reactive sugars and reactive residues on proteins. And they make this menagerie of molecules that kind of gum up the works and mess up like lysosomal breakdown capacity and cause cross-links between long-lived tissues that lead to loss of elasticity in various tissues and organs, and then eventually lead to things like heart disease and cancer, and have all sorts of upstream effects mucking around with human health. But these things accumulate in your body as a side effect of normal metabolism. They accumulate about twice as quickly with diabetics, which is why, to some extent, diabetes is sort of a segmental progeria. It's a form of accelerated aging when it comes to certain cellular and molecular hallmarks of disease. And so some of the very first sessions with Dragon Tyrant Must Die will involve reagents where we've just mixed sugars with various proteins, including things like collagen, which is one of the things that becomes most cross-linked as we age. And looking for different age-related advanced glycation end products and cross-links and other forms of molecular damage that increase our odds of death as we age. And Dragon Tyrant Must Die, the entire first year of that game is going to be about method development to be able to see all these different hallmarks of aging on a molecular and cellular level. And then that game will actually morph into experimental workflows to look for interventions that we can find evidence will work molecularly, either in a culture dish or in vitro. And later on, the more advanced versions with the later gen consoles will actually undertake like population scale interventional strategies and things we might think of now as clinical trials. Although I think in 5 to 10 years, the idea of a clinical trial is going to morph into something else. Especially if we have really powerful, easy to use tools for looking at various cells and molecules that people are just starting to get used to having around them. So that's just one example, and you could pick any of the other games we've talked about, and we can kind of look at how we can do science with solid state nanopores in that field. So Molecules of Mars. Just stop me if you have any questions, because I can just go through the games.
Yeah, I wonder if you can give a bit of a flavour of how the gameplay will work. So, for example, Dragon Tyrant Must Die. How would you play that?
So, Dragon Tyrant Must Die. So the very first quote unquote episode or installment of Dragon Tyrant Must Die is going to be a live kickoff event. Where we'll have some people from the biogerontology community there talking to us, and it'll literally be this summer when people are just starting to get used to using the console and dealing with its quirks and issues, and and that'll basically that'll be we'll combine the idea of something where you can get sort of satisfaction that you won or you earned some points within like a half hour collective session with other people. But then the game is going to become longer form, like a role-playing game where you divvy up into tribes with your friends online that you're playing the game with, and you go after this map of the Dragon Tyrant. So the first year is going to be trying to fill in this sort of, think of it like a map in an old-style RPG fantasy game. Where you're trying to fill in the map by visiting every portion of it. There'll be this Dragon Tyrant image that basically represents the map of different things we want to get positive ID on with nanopores that are different hallmarks of cellular and molecular damage, different cellular and molecular forms of damage that accumulate as we age. So you could go down the list of... in particular, Aubrey de Grey's way of dividing it up into 7 main types of forms of cellular and molecular damage. And then we can have other things like that correspond to this map that are not really strictly speaking the cellular and molecular damage, but other things that people kind of argue about could be hallmarks of aging that are somewhat universal, like giant lysosomes. I know an aging researcher who thinks that should be the 8th category. And so the goal the players would have would be to fill in this detailed map and to bring out its color and its detail as they establish the ability to see these different cellular and molecular features. And that's basically just method development with nanopores to go after targets in biogerontology.
So in practice, the players would be swapping out different nanopores and mixing different targets together and trying to get the best signature possible to identify those targets? Yeah, exactly. And behind the scenes, there'll be people who are more on the game development side, who are actually digging into all of the data and aggregating it and deciding what the shifting targets are and where to point people to look. That'll be, that'll kind of combine, you could imagine that as a combination message board, place to go to start seeing your raw data. And then that the game itself is like an experience that kind of maps onto this raw data acquisition in a way that makes it a lot more fun than like having to plan out detailed experiments and sort of analyze the data yourself. So does that mean you'll have like people like gerontologists on your core game development team?
Yeah. We have one of the world's most famous biogerontologists helping us out. His name is Aubrey de Grey. You guys might have heard of him. Has this formerly controversial kind of, I consider it a hypothesis around aging and cellular molecular damage. But that's also closer to my wheelhouse. And there are several other people who could get involved in that. We're hoping, particularly with the alpha test, that with the alpha testers we have a critical mass of people who don't want to just play the games, but actually want to contribute to early development of games. And so it's really going to be, in the ideal scenario, you could look at how like something like EVE Online or World of Warcraft, like so much of the value of the experience is brought by the players themselves and the choices they make. And if we have something analogous to that, it'll really help it take off. Where there are people who they might not otherwise go through a PhD program, but they've got a hacker mentality. They might not be in the right place to be, at MIT. But if you give them a simple tool to play with, if you make it as easy as like turning on a laptop, then I think how deep they could go is hard to say. I mean, look at the deepest, best players of Foldit and Eterna are like really out there, understanding things that postdocs in Baker's lab might not have understood yet. But this is really about the proliferation of this really basic tool that just lets people see single cells and molecules, bringing in people who would otherwise kind of self-deselect because they're not at a research institute, or they might just habitually be sort of a hacker mentality, which is like requires a lot less physical activation energy than being like a wet hacker or a hardware hacker. You can put so much of your brain into this purely abstract thing. This world of bytes and bits it's so much easier. I think it's such a better funnel for like human intellect.
Yeah, is that what excites you the most about demonpore? The sort of engaging of the community, or some other aspect?
Well, so I'll tell you, the thing I'm most excited about right now is what's going to happen this summer. Because just the ability to do any kind of solid state nanopore experiments with multiple materials with just a few hundred different combined channels of data is not something you can buy right now. And in a sense, in a very concrete sense, like that first league of players, those first few hundred players, they're going to make the most powerful solid state nanopore platform ever built, even with just a few hundred people. And that gets the scientist in me super excited just to see what we can do with that. I am very much interested in scaling tools for synthetic biology, making them faster, more powerful, cheaper, etc. That's what's been in my heart for more than a decade and what really motivates me. And the gaming aspect also motivates me because it feels very populist. It feels like it's kind of a way to claim by greatly expanding the market for these kind of things, for single molecule and cellular sensors. By greatly expanding that market, I feel like we're claiming attention for something important that isn't getting enough attention.
Talking about the raw data and the game development, like how multi-dimensional is the data? So like what kind of, I guess the real question I'm trying to ask is, based on the kind of data that you get and like the dimensionality of the data, what genres of games are compatible? Like, can a first-person shooter be created? Could an RTS be conceivable, or is it mainly RPG style? Kind of the game has to go at the pace of, say, the actual data coming in. You know.
A great question. So I think okay, so. First-person shooter, we're literally working on that, but it's actually not first-person, but it's a shooter, and it involves it's. I don't want to give too much away because this is going to be so cool when we drop it publicly, but it's basically a space-based shooter where enemies are generated by patterns of translocation spikes. And it is just designed to create a kinetic, fun 1980s style arcade video game experience from raw nanopore data. And it's the one compromise where we're just like, okay, let's design something that somebody will have a blast playing without knowing anything about the science underneath it. And they just know that by putting these different combinations of things into the pore, they can generate all these different enemies and these interesting experiences of things that they can do battle with. So that is just our appeal to the gaming industry people, to the will this be fun people who aren't necessarily ever going to become really player scientists. So yeah, we're definitely we're in the weeds on that one, and we're close to showing something pretty cool. You're right to observe that the other games are not so kinetically oriented. They're not like action shooter, like fast sort of paced games. And I think that's fine, because I think we figured out a way to have our cake and eat it too, or to have both types of games.
So what's the hardware like that you're actually like? So you've got the nanopores, but then the console itself, what's the hardware like? What's it capable of? Like, is it like is it like a computer, like an x86 based system that you have written an OS for, or like is there some custom silicon that people need to learn how to program?
So there's no programming involved for the end user. There is what we call the hacker board, which is, I think it's the version we're going to ship this summer, where there will be potential for hardware add-ons and accessories. But as it is, what we have is a custom transimpedance amplifier that is the one thing we really had to design, and basically that just like how the circuit works is that it has to you set a voltage, right? So you're telling these electrodes to have a certain amount of potential energy in them to create ultimately create this electrically induced flow of ions through the pore. You've got electrodes in solution, and what the transimpedance amplifier lets you do is keep injecting enough current to maintain that voltage, and report out what that current is in such a way that you're basically measuring the current through the pore itself. And we have an analog to digital converter and a digital to analog converter, so we can go both from telling it what to set the voltage at to getting out the current that results, and a microcontroller as well. Like everything in the box on the electronic side is coming in under tens of dollars, and the next generation version. The next generation version that we'll start to develop with sufficient capital will basically take all that and shrink it down into an ASIC and give you thousands of channels for the same footprint and cost. And that's the second generation play. The second generation play for us is to actually make things that can do actual FDA-approved diagnostics. The demonpore 64 is just a very basic research tool with this advanced single molecule and cellular sensing capability, but a single instrument won't have the throughput to do any kind of meaningful diagnostics.
I think maybe I didn't ask the question like clearly, like very clearly. What I meant to say was, like, say I'm a game developer and I'm interested in the capabilities of like the hardware, like the compute, like what it can like produce, what it can display on a screen, for instance. Or is the demonpore 64 just the sensor, or does it actually contain a computer which does actual, like, I can develop a game which runs on it?
No, you don't want to develop a game that runs on it. What you would do is you want to develop a game that runs on it, because the stuff that happens on it, the stuff we would actually happen on it is all about signal processing and pushing that up to the server.
So I plug my Demon 64 into my computer and I play the game on that.
Yeah.
Right. Okay, sorry.
Right. So
from the picture, it kind of looked like a console that I plug into my TV, and then I would like hook up a standalone box. But I do need a computer as well.
No, you just need. So the idea is that you just need a browser.
Oh, okay.
So no software install. The thing that we're shipping this summer, you need an Ethernet cable. It's not wireless. So you just need to be able to plug Ethernet in and go to a website. And currently the website we go to is just this thing. It's not moleculartv.com. That'll actually be live later in the summer. But the idea is, so the interesting stuff you'd want to do as a developer to like become a dedicated, okay, I'm going to develop games on this. That'll definitely start with the science. Like, you'll want to think about, or we'll want to have some way of sharing and talking about basically the entire corpus of nanopore literature and the kinds of questions people have asked and gotten answers to that are based on nanopore data. The biggest chunk of those are just all the biological things that people have gotten with the MinION, with the Oxford Nanopore instrument. That's all based on sequence data. But if you just go out swimming in the nanopore literature, you'll find people looking at every different kind of thing there is to look at in molecular and cellular biology. And, it's kind of it's just a good, it's like, what would you want to do with a greater ability to see cells and molecules? And then you'd have to know like the trade-offs between what you could get out of a fleet of demonpore 64s versus what you could get at your research institution.
So like once I'm generating data, where does the computation happen? Does that happen locally on my computer in my browser, or does that happen on a server somewhere else? Because from what I understand, at least with the Oxford Nanopore instruments, you need quite a beefy piece of hardware to actually be able to do like live reads of sequence data as it comes in. Otherwise, you need to wait a significant amount of time. Like you need a lot of processing power, at least for the Oxford Nanopore. Is it the same for the demonpore data that comes through?
Yeah, it's a bug and a feature. So, I think so we developed some software that was closer to like developer view. Okay, like you're willing to have beefy software. You're willing to deal with like doing your own analysis of the raw data. I'd want to make that very open and available. For just like the person who wants to play molecular games and see what happens, I don't want them to have to do anything but go to a browser and have fun. But for developers, yeah, you're right. Like it's so what you would get into quickly is a lot of machine learning, a lot of time on the cloud, data storage costs, etc. For just the random generic player, what we serve to them is a representation of data and not the raw data, because the raw data is a lot.
But so how do I build out an infrastructure which can handle? Because let's say I'm one of the researchers and I'm trying to parse the immense amount of data that's coming in.
Yeah.
And then feed it back as something as a stream which like the game interface can translate into something that can play. How do I build out like the infrastructure which with such an immense amount of computational power to handle so much data coming in? Is that up to the game developer and the scientists, or is it something that demonpore will handle with a massive server farm or something?
Yeah, it's both actually. So what we've done internally is like, for instance, for Spike Hunter, it's not that computationally intensive to just say, okay, this is a spike, and to report its parameters. That's not the deep computationally intensive thing. In fact, like some of the more interesting machine learning stuff that we've seen that we're going to be replicating, it's either open source or it's not super computationally intensive. So I think the sequence data calls and all the processing issues involved with the MinION, I think that probably has to do with, so you don't have machine learning. you don't have the algorithms. Actually, if you're, I haven't looked at a MinION myself in a couple of years. I'm not sure where we're at with that. I remember it being something where you had to load everything up onto the cloud. You had to wait for it to come back. It was not necessarily a walk in the park to get the raw data at all. And I don't like, it's a wonderful product. It's really cool that people can sequence DNA with something that's just USB powered and fairly easy to use. It's a beautiful product. So I don't want to knock it at all. Their computational challenges are much greater than ours because we're looking at a single channel per instrument. And in many cases, you can throw out most of the raw data. What you really care are about the shapes and the parameters that you can extract from the spike features. That's the most important thing. We will need to build a machine learning infrastructure, a data storage infrastructure, a back-end infrastructure that we don't have now. And we've made progress to sort of mapping that out, and we have a sense of what it's going to look like. But there's definitely a lot more work to do there.
So how would a gamer actually interact with the device then?
So opening it and closing it and putting stuff into the reservoir and also switching out nanopores. So this is, I can just show you guys, this is actually a slightly deprecated basic design. I don't know if you can see that. This is one of the nanopore cartridges. I don't have the newer ones with me now, but basically this has about a 10 micron KOH hole in it. This is like a good sweet spot for looking at like erythrocytes and whole cells. And basically this kind of clunky. This is not like beautiful ergonomic design yet that we're going for, but it did. You would slap this down on top of one of our older flow cells and basically just tighten 4 wing bolts, and then you could put solution in, and there's a little hand cranked syringe pump on the other side of it, so you could pull solution through. And that's basically how we played the first games of Spike Hunter, just looking for large aggregates, looking for larger things like whole erythrocytes that would produce a signal in this. And then you have to close the lid and make it electrically quiet because the whole thing has to be Faraday shielded. Because the circuit is very sensitive to electronic noise, and that's basically most of the interaction time. Is that most of the time you're on the browser window, and some of the time you're exchanging fluids and switching out nanopores.
So the user needs to put liquid mixtures to the device. I wonder if how much does it cost for one round of game, and if will it be enough for users to play the game? If they make any mistakes, is there a way to redo it, and how many times can a user play one game?
So these can cost. We can get these down to pennies, and they can also be regenerated and cleaned if they become clogged and you're not able to use them. And it's different for different types of nanopores. There are some pores that we're actually going to have to ship pre-wet. So they're already going to have a fluid path across them, and you're going to peel you're going to peel these little PDMS stickers off of them and then fill the reservoir. That's one way to do it. But because wetting is a special issue with nanopores, especially when you get down to smaller ones. And I'm sorry, your question was about the cost of consumables, the cost to play a game.
And how much liquid it requires for one round of game, and how much liquid mixtures do you provide when the user purchases the device?
So we're going to identify different sets of reagents that are interesting for different games. And we're going to have to make those reagents, make them available as sort of a kit that you get that lets you play that particular game. So this is all going to be on demonporium.com, which is basically going to be the online store for Demonpore. You're going to be able to buy different combinations of nanopore cartridges that are recommended for different games, and different combinations of reagents. So obviously we want to keep the costs down. We're not so concerned about that this summer. Our goal is we're not going to make money off of the alpha test this summer. So we'll probably spend more than the actual cost of goods to get all the right reagents out to people. And we'll also be providing hardware upgrades because the hardware is not going to be final either. Reagent costs is a really good question and you want to get creative if you don't want high reagent costs. So one example is if I just want to get some NIST standardized nanoparticles, we're looking at $300 for a little vial of 10 milliliters of NIST standardized nanoparticles. And that obviously puts the price way outside of casual fun gaming experience. We really want it to be pennies or at most dollars for the reagent kits. And there are a number of ways we can do that. So for instance, those polystyrene beads, it's the fact that they cost that much is all about quality control and lack of demand. If we had to get polystyrene beads out to everyone, out to millions of people, the cost would quickly start to approximate the amortized cost of the equipment and the raw materials, and it would be pennies for polystyrene beads. So we have to get creative about how we're going to produce these different reagent kits when we're selling tens of thousands or millions of them. The alpha launch, the costs won't be so sensitive, and we'll probably do whatever's most convenient to move quickly. For a lot of the reagents, though, if you just think of the world of different kinds of interesting things to put through a pore, different standards, there's a lot of ways you can make things cheaply. There's a lot of ways you can source sort of an infinite diversity of stuff. So one of the games I'm most excited about from that perspective is Gastromancy, because basically you're gonna wash and filter things from your refrigerator in the form of a cooking game. So the reagents don't get cheaper than food. So that'll be a fun one. And then there are examples like the one I told you about, Dragon Tyrant Must Die, where basically the reagents are just supermarket gelatin that you incubate with different sugars and simple things like that should give you reagents really cheaply. So it's still early days, lots to figure out. I'm glad you guys are just jumping right into the more than anyone else, I want you guys to see the console being used and see games happening. And I hope very, very soon we can create some experiences for people around that.
Yeah, I'm really excited to get started with these games. We actually had a question from one of our listeners. He wrote in, Mike Norton. So he says that he isn't much of a gamer, but he is interested in whether the demonpore might be usable kind of in more traditional lab environments, for more traditional experiments. Is that a thing that it can also be used for, but with a much cheaper cost than traditional nanopore devices?
I've kind of been assuming that that's just going to happen, or hoping that that's just going to happen. I guess I'll put it this way. My reluctant business imagination, if it weren't for the need to try to get as many people as we possibly can playing around with these things, I would just we would just be talking to academics. We would just be like, I would drive over to Stanford and like just walk into Drew Indy's lab with one of these things and just say, here, play with it. And there'd be somebody who would be like putting stuff through it and seeing what happens and thinking about how they would just use it as an instrument for their workflows. And that's awesome. But I also think with you guys, with people in Indy's lab, I kind of want to say, well, what would you do if it were actually a high throughput instrument? And this is not the high throughput instrument, but these few hundred people who are going to be playing around with it, they are a high throughput instrument. So what sort of interesting questions and insights could you get out of it? And of course, like, I don't want to knock either, just like, if someone wants to just play around with single solid state nanopores, which is what so much of the actual nanopore literature is just people with these sort of bespoke solid state nanopore systems with different types of materials, etc., getting proofs of concept that in many cases are kind of one-offs, just to show that they can detect this or that thing in this different context. If people want to use it for that, that's awesome. It's sort of like, everybody makes the joke, can it play Crysis? If you guys know that reference, it's a video game world joke. You'd also say, like, can you play Doom? Like, I would expect people to play Doom and Crysis on the demonpore 64. But just as I would expect, like, if some creative iGEM kids get their hands on it, they're going to do all kinds of wild things with it I can't anticipate. And I don't see why it wouldn't have that sort of open architecture. But it's not the marketing focus, because I think that people who already would know what they would do with solid state nanopores don't need to be sold on the video game approach, except to the extent that it would give them something potentially more scaled and powerful.
I want to kind of switch gears a bit and find out a bit more about you as the person. So you started off in academia, and what made you kind of leave academia and become an entrepreneur?
Oh, wow. So yeah, I only like went into academic science, or I only got committed to it because I wanted to, I'd say, fulfill these sort of like over the top sci-fi ambitions that I had as a kid, and also sort of that it connected back to my childhood, where I was like this very introverted, very technical kid, and then I became something else entirely different. And I didn't kind of go back to that sort of scientific, technical, really learning difficult subject matter sort of mentality until much later. And when I did, I fell in love with the discipline of drosophila genetics, of all things. Like that was this beautiful excursion into this genome that is way smaller than the human genome, and I probably spent 500 hours on Flybase just looking at genes and doing recombinant mapping, and got some really good results. Spent like 3 years working on this project that I took up from a postdoc who had preceded me in the lab, who published something that as an undergrad I found out wasn't really valid, and then I was like stuck with 3 years of work and this sort of like invalid result from this previous postdoc that I was supposedly building on, which had to do with whether or not this thing was just a transcriptional effect, or if it actually had to do with something, if it actually had to do with this delicate ballet of molecular events that lead to a fly's wings being stuck together when it comes out of its when it emerges as an adult fly. And that was work I did at the Arizona Cancer Center that gave me an appreciation for the molecular molecular biology and the central dogma that I lived and breathed for a number of years. But when I was close to graduating, I met the founders of Halcyon Molecular, and I absolutely fell in love with what they were doing. And I completely bought into the idea that I could have a much greater impact if I worked on tools, on fundamental tools, because I had just spent 3 years hunting down molecular mutations in Drosophila using classical recombinant mapping techniques. And at the time, we were not allowed to use our access to the next-gen sequencing facility, so everything was Sanger. And I did so many PCRs and submitted Sanger reaction runs because recombinant mapping defined various loci, various mutated genes in Drosophila. It usually doesn't give you like single gene resolution. You just know you're within like 10 genes of some mutation, and you have to get clever. So basically, this is in a sense the very first sequencing technology ever, is just having flies have sex and looking at how their phenotypes are assorted in the offspring is like the original DNA sequencing technology. And it's absurdly slow and low resolution. But that experience, killing millions of flies and trolling through the Drosophila genome for all those years in search of answers, that gave me an incredible appetite to care about tools. And also, like near the end of that experience, near the end of that, I also worked for the Methuselah Foundation, and was involved in another project that made me want to abandon actual science and just focus on tools. And that involved finding enzymes that could break down age-related aggregates as part of the LysoSENS project. And both of those experiences combined made me say, wow, I want to go all in on developing tools. And my friends Michael and William Andreg, who founded Halcyon Molecular, they had developed this way to pull single DNA molecules into air. It was incredibly cool. And they could pull single DNA molecules into air and stretch them out and place them onto these ultra flat electron transparent substrates, and have heavy atoms base selectively attached, so that the pattern of these little heavy atoms on this straightened DNA backbone would report the sequence of the DNA. And this was actually the first, this is based on something Richard Feynman said in the late 50s. He proposed a specific method involving electron microscopy to sequence DNA, and as best we could tell, it's the first time anyone, or at least that there's a record of it, that anyone proposed a specific molecular method to sequence DNA. Richard Feynman said you just look at the DNA using aberration-corrected electron microscopes. And 50 years later, we did it in Halcyon Molecular. We actually sequenced DNA that way. And that was a big adventure that lasted multiple years and involved me getting to learn a lot of things about managing large teams of researchers and about all the Murphy's Law that goes into company building. And that didn't work out, but it wasn't about the science. And that taught me a lot, that great science does not necessarily make for something that works out in terms of money and the world of business.
On the topic of lessons learned, and maybe our last topic that kind of goes back to the very beginning of this podcast, would you say, or can you think of any lessons you learned in theatre production that have translated and kind of come full circle and helped you out with demonpore?
Yeah, I think okay, so we're talking my late teens, early 20s, and I was in that 12-15 year period of my life where I turned away from being a geek and I became a different kind of geek. I became like this pretentious, hyper literary kid into postmodern literature and performance art and all these kind of silly human things. And I lived in a theater, and I was involved in like 50 different productions and wrote plays, directed them, etc. And I know that came from like this transition in my childhood where I had the kind of like semi-stable home life without too much drama that I think is very helpful if you have like an introverted, nerdy kid who wants to read all day and do science. And that like my personal environment changed into something that was a lot more emotional, chaotic. There was a lot more precarity in my life, a different set of characters, so to speak. And that kind of forced me, that made me become this very sort of provocative, emo, angry kid who no longer had the patience to like learn programming languages and read science textbooks. Like I wasn't rebelling against those things, but I just needed this immediate emotional outlet, and I found it in art. And something I think, just to answer your question, is that I think one way it's like, okay, so it's like I'm a multi-class character if it's a role-playing game. I get to be like magic user and fighter. I don't know what the analogy is to like having this weird artistic background and being a scientist, but I'd say one thing where it was always useful, I don't even know if it's useful more than it's just human and it's interesting, is that when you're trained in theater, when you're trained in acting, you develop a dissociation, if you're any good at it, between your emotional self-presentation and your actual feelings. And it's not at all that you like go through life denying the feelings or faking your emotions with people. That's not the value of the gift. The value of the gift is that is sort of encapsulated in this thing that the best actress I ever knew said to me. It's that everyone is always acting. It doesn't mean everyone is always deceiving you or being what they aren't, but I have this other level. I have this other sort of skin that I apply to interactions, where I can sort of separate a person's body language and their tone and their gestures and all these little details, and I can step back and I can sort of empathize with them on a deeper level because I can be them. I can put myself in their mind as a function of their body language, etc., etc. And occasionally that's useful to do because it really helps you relate to people, and it helps you it helps you sort of penetrate to a different level. I think it's part of what makes me a good technical recruiter, and it's part of the skill set of a CEO more so than being a good scientist is. But it's also, it's one of those tricky things. It's like it's the spiritual side of all of this, whatever that means. But you don't have to sell your soul. It's just named for Maxwell's demon. Just to bring that full circle.
That's a really interesting perspective. I never thought of it that way. Thank you so much for joining us, Kent. We're really looking forward to playing around with one of these as soon as possible. Stay tuned for our next podcast in a couple weeks' time when we'll be talking to Lee Organic, and thanks for listening.